Hello students, welcome back to my channel Positron. Dear students, today's topic is a ray optics second part, right? Today's topic is a plane mirror, how you can make the images with a plane mirror. Undoubtedly, this is not a part of your 12th syllabus, I think, but from plane mirror, so many questions are asked in NEET and IIT. That is why it becomes important for me to let you know about plane mirror. Dear student, we are studying ray optics. In my first video, I have discussed with you all that what light is actually. You know, light has a dual nature. It behave like a particle, it behave like a wave. And ray optics is that part of optics in which we do consider those properties which reflect the particle nature of light. For example, we talk about reflection, refraction, that is a scattering, dispersion, a lot that we have to study. So today's topic is in this video I will discuss about that how the images can be made with the help of plane mirror, and after that in the next video I will discuss about the spherical mirror, and in next video that will be based on the spherical lens and lens formula, mirror formula, so many things we have to study. Dear students, today's topic is a plane mirror, right? How the images can be made using the plane mirror. Dear students, this is a plane mirror, right? Let you are standing here. If you are at a distance small L away from the mirror, then just take a ray like this. Your image will be made at the distance away from the mirror, such that whatever is your distance from the mirror, your image will be made at the same distance behind the mirror. Dear students, you can say your mirror is the size of your mirror is equal to size of your height, right? The size of the image is equal to size of yourself, right? If you are 6 feet, then image will be 6 feet. Dear students, look here. You know, the one ray I have taken normal, that will be reflected back. Okay? Another ray, look here. Yes, I am taking like this, and this ray will be reflected like this. Now, these two rays are intersecting here. That is why the image will be made here. Now, dear student, this ray intersect this particular ray when you produce back to meet it, right? So, really they are not intersecting, but virtually they are intersecting. That is why the image will be virtual, and the size of image will be equal to the size of object, and distance of image from the mirror will be equal to the distance of object from the mirror, right? Dear students, so in the case of plane mirror, the image made is a virtual and erect, right? Why virtual? Because the rays are interfering. That you know, in order to make the image, the basic concept is that you need two rays to intersect. These two rays are intersecting virtually, not really. That is why the image is virtual, but the image is that is erect, right? Means the erect means if the object is like this, then image will be made like this. And if it is like such, if it is not in this case, then it is called inverted. So dear student, this is the way to make the image. Let's discuss something more about the plane mirror. So one thing came clear, that if the object is x distance away, image will be also at x distance away from the mirror. If the height of an object is h, then the height of image will be h. Our image is virtual and erect. Now, dear students, what I said, that image is virtual and erect. What should be the height of minimum height of a mirror, so that you can see, you can watch the complete image. That is, if your height is small h, then height of mirror should be h by 2 to watch complete image. In order to watch the complete image of yourself, if your height is small h, then the minimum height of mirror should be h by 2. Now, dear students, let's talk some important facts. What happens? I've taken an object which is x distance away, right? Now, and you know, the image will be made at x distance away from the mirror, behind the mirror. Let object moves distance small l either towards mirror or away from the mirror. Then what happens? If it moves, the object moves towards mirror by a distance small l, then image will move also a distance small l towards mirror. So between image and object, the distance is decreased by 2l. If object is moved small l distance towards or away, if it is object is moved towards small l distance towards the mirror, then image will also move small l distance towards mirror, and the distance between the object and image will be decreased by 2l. What happens if object moves away l distance away from the mirror, then image will also move l distance away from the mirror, then the distance between object and image will be increased by 2l. Now, dear students, what happens? Let a boy who is running with velocity u, a boy is running with velocity u towards the mirror, then image will also move towards mirror with velocity u, right? If the boy is running in front of a plane mirror with velocity u towards or away from the mirror, then the image, if the boy is running towards the mirror, then image will also run with the same velocity towards mirror. If the boy is moving away, then image will also move away from the mirror with the same velocity. In this case, now the velocity of image with respect to object, either it is moving towards or away from the mirror, right? In both the cases, look here, in both the cases, the object and image will move opposite to each other, right? If it is moving in this way, then image will move in this way. If the object is moving leftward, then image will move rightward. In both the cases, they are moving opposite to each other, and in this case, you know, the relative velocity will be u minus u, that is 2u, right? Now, what I have written, that velocity of image with respect to object, that is u minus u, that is a VAB is equal to, you know, that is a VA minus VB. Dear student, this is moving, it is moving in this way, rightward, means along the positive x direction, right? So its velocity will be plus u minus, and this is moving towards in negative x direction. So this velocity we will consider minus u, and it will become u plus u equal to 2u. So what we have got, that if the object is either moving towards the mirror or away from the mirror, then the velocity of image with respect to object will be VAB is equal to VA minus VB. Either it will come to you or minus to you, no matter. But the velocity, relative velocity of the image with respect to object will just be double of its original real velocity. Now, dear students, let us start. That is, we are talking that we are talking about the plane mirror, right? What we have discussed, that if you are at a object is at a x distance apart, then the image will be behind the mirror x distance apart, right? If object is moving with velocity u either towards mirror or away from the mirror, the same. If object is moving with velocity u towards the mirror, then image will also move towards mirror with the same velocity. If the object is moving away from the mirror with the velocity u, then the image will also move away from the mirror with the velocity u, right? The minimum height of the mirror, the minimum height of plane mirror, so that you can watch your complete image. If your height is small h, then the height of mirror, minimum height should be h by 2, right? The minimum height should be h by 2 to watch the complete image, right? If your height is small h, the image of your, the height of your image also will be small h. Means that in the case of plane mirror, the height of object and height of image will be equal. Now, dear students, we are talking about the plane mirror. Now, very important thing, that what is the focal length or radius of curvature of the plane mirror? It is infinite. Dear students, it is infinite. Simply you can say spherical mirror is a part of a sphere. Just because I want to tell you about that, why it is infinite, that is why we have to take this example. It is a sphere, and a spherical mirror is cut in this, right? In this way. You have taken a part of this. This is the spherical mirror. Now, it's a center of this sphere is the center, and this is geometrical center of the lens or mirror, right? And from center to geometrical center line joining is called the optical axis. Dear student, this is the center of the sphere. So, radius of curvature, the radius of that sphere is the radius of that sphere of which your spherical lens or mirror is the part, is called radius of curvature, right? Radius of curvature is what? The spherical mirror or the lens is the part of a sphere. So, radius of that sphere is the radius of curvature of your spherical mirror or lens. Now, dear students, what happens if it is a bend like this, right? It is just open like this. Then this center will be this. Radius of curvature will be this much. If it is bent like this, and this center will be more away, move far and far. And if it is plane, then what happens? The center will go to the infinite. So the radius of curvature will be infinite and focal length will be infinite. So in the case of plane mirror, focal length or radius of curvature is infinite. Now, this the most important part is making the image with the plane mirror. Number of images in plane mirror. First I am discussing a simple formula, then after that a lot I will discuss that how these images can be created. Dear students, number of images in a plane mirror. Actually, the number of images you have to classify it into many groups. Number of images, m is equal to 360 over theta minus 1, where let 360 over theta equals to n, right? So number of images m is equal to n minus 1. Case first. If n is even, if n is even, then m is equal to n minus 1. Where theta is the what? Theta is the angle of inclination or the angle between the two plane mirrors, right? If this is n, m is equal to n minus 1, right? If n is even, then m is equal to n minus 1. For example, let theta equals to 90 degree, then number of image m is equal to 360 over 90 minus 1, that is 4 minus 1 equals to 3. If theta equals to 60 degree, m is equal to, if theta equal to 60 degree, m is equal to 360 over 60 minus 1, that is a 5 minus 1, that is equals to 4. If theta equals to 30 degree, that is 12 minus, 6 minus 1, that is 5. If theta equals to 30 degree, that is 0 cancel, 12 minus 1, that is 11 images will be made. Now dear students, what happens if rest of the part I am writing here. Case 2. If n is odd, when n was the even, then number of images were m equal to n minus 1. When n is the odd, there are the two cases, right? Part A. When object is symmetrical, symmetrical means it is kept just at the mid of, or it is kept at the angular bisector. Object is kept at the angular bisector of the two mirrors, right? In this case, what happens? M, number of images is actually n minus 1, right? When object is kept symmetrical, m is equal to n minus 1, right? But what happens? If object is not symmetrical, then number of images will be m is equal to n, right? In this case, number of images will be m is equal to n, right? In this case, m is equal to n. Now, let's find example of this one. For part A, I am considering m is equal to n minus 1, n should be odd. So let theta equal to 120 degree, right? And object is symmetrical, means this is the two mirrors at 120 degree, right? Object is symmetrical means object exists as somewhere on the angular bisector, that is 60 degrees, that much 60 degrees, that much, let the object is here, right? So from first mirror it is making a 60 degree, and from second mirror it is an angle of 60 degree. In that case, what happens? M is equal to di string 360 over theta. Theta is a 120 minus 1. 123 is that is 3 minus 1, that is equal to 2. But what happens? In the same case, if you consider that is a object is here, this one is a 90 degree, this one is a 30 degree, and whole angle is 120 degree. Now, object is not symmetrical, object has not been kept symmetrically. In that case, m is equal to actually n. N means 360 over theta, that is a 120, and this, in this case, there will be 3 images will be made, and in this case, only 2 images will be made. Now, by the ray diagram, you can prove either so many methods are there. Just after that, we will discuss spherical method, crisscross method, so many methods. That how the images are made between the plane mirror, between the 2 plane mirrors. Dear students, let's discuss one by one. The image between 2 plane mirrors kept parallel to each other. Let the 2 mirrors are this. Yes, they are kept parallel to each other. Dear students, these 2 mirrors are left 2L distance apart. This one is a M1 and this one is a M2. What happens? Let just at the mid, an object or a boy is standing here. Means from M1 it is at a distance L, and from M2 it is at a distance L. Or a point object we have considered this is. Now, image of this object from this mirror will be, draw a long line. So it will be easy to understand. So many images we have to make. Image of this object by this mirror, the object is at L distance away from mirror M1, so the image will be, image of this real object from mirror M1 will be just at L distance away, and let it is I1, right? Dear students, again mirror of this image of this object by mirror M2, this is again small L distance away, so it is at L distance away, let this is I2. How these images are made, you can make. Let one ray you have taken this normally, and it will be reflected back. Another ray I am taking like this, right? It will be reflected back like this, right? So the image of object O is made at I1. And now, dear student, in the same way, you can say like this, right? And take a reflection from it. Means actually it appears, this ray is reflected from here, appears to come from I2, right? Now, dear student, this image I1 will behave virtual object for M2. This image the mirror M1 has made image I1 of object O, right? O was the object of which image has been made at I1 by mirror M1. O was the object of which mirror has been made at I2 by mirror M2. Now, dear students, this I1 will behave as the virtual object for M2, right? So it will make the image of this image, and this is from here it is 2L plus L. So at 3L distance away, look here, this I1 will behave like a virtual object for M2, right? So the image I1 is at, this is 2L, this is L, so 3L distance away. So another image will be made from 3L distance away. This is L, so at 2L distance, or you can say it is a 3L distance, and this will be image of I1, and that is let I1 dash, you can say, right? It is I1 dash. Now dear students, this I2 is the image of object by plane mirror M2. This I2 will behave like a virtual object for mirror M2, and it is at this distance is L, so it is a 2L. Again it is a 3L distance away, so the image of that will be made at 3L distance away from mirror M2. So it is L and this is 2L distance, so it is a I2 dash, and so it is a, sorry, this whole distance is a 3L, right? And how you can make this image? Look here. This was a I1, and yeah, it was an image of I1 made at I1 dash, right? The ray is reflected from here, appears to come from I1 dash. In the similar way, look here, for this ray will be reflected in this way, right? There are so many rough you have to do in the physics, no matters. You should just, I'm trying best you to let you to know. Now, this ray, actually it is coming from here, right? It will be reflected in this way. The reflected ray appears to come from I2 dash. So, the image of I2 will be made at I2 dash. Now, the I2 dash will behave again a virtual object for this, and this I1 dash will behave a virtual object for M1, and in so many images. So, the number of images in this case, dear students, there will be infinite, right? If you go for the shaving, hair cutting at the salon, there are the parallel images kept. So, number of images you can see of yourself. Dear students, again I am repeating my words. What was that? Here was an object. The two plane mirrors were kept, right? Let these two mirrors are 2L distance. The two plane mirrors are 2L distance apart, and the object I have taken just at the mid. Wherever you want, you can take between these two plane mirrors. Now, I have said even initially that the image made by the plane mirror is a virtual, and a virtual is what? Because the two rays do not intersect really, but virtually you have to produce in order to intersect. Now, the image of object O is made by M1 at L distance away. Let it is I1. Image of object O is made by M2 at distance small l, because it is the distance between the two mirrors is a 2L. Object I have kept for the convenience just at the mid of two mirrors. So this is L distance away from both the mirrors M1 and M2. Now dear students, what happens? The image made by M1 of O, which is L distance away from mirror M1, that is at L distance behind the mirror M1, and image of O is made by plane mirror M2 at I2, which is again L distance away from the mirror. This I1 will behave for virtual object for the plane mirror M2, and this I2 will behave as a virtual object for the mirror M1. Now, the M2 makes image of this image I1, and M1 makes image of this image I2. In this way, you will succeed, and you will get that infinite images are made if the two mirrors are kept at parallel to each other. So the image will be infinite. Even at the beginning of this video, I have discussed with you all that plane mirror has the focal length infinite, radii of curvature infinite. Why it is, I have proved. Now let's move further. Dear students, how you can make the image? If the two plane mirrors are perpendicular to each other. If the two plane mirrors are perpendicular to each other, right? And the object is symmetrical. Object is symmetrical. First, let's test from our formula that how many images will be made. M is equal to 360 over theta minus 1. That is first test. N is equal to 360 over theta. Theta is 90. That is 360 over theta is 90. 94, that is 4. So it is a 4. 4 is an even number. So N is an even. In the case of even, it does not matter, right? So the number of images will be n minus 1, that is 4 minus 1, that is equal to 3 images will be made. In this case, the number of images will be 3. Now we have to prove that by the ray diagram that whether it is true that images will be 3, 2, 1, how many number of images will be there. Let's discuss. It means there is no means whether it is a symmetrical or non-symmetrical. It means if the two plane mirrors are like this, right? Whether you kept symmetrical means it is 45 degree. The line on which object exists is making 45 degree from both the mirrors, or the line is making just 30 degree from one mirror and 60 degree from other mirror on which the object is existing, right? If n is even, then number of if 360 over theta, I mean n is even, then number of images will be n minus 1, no matters whether n is no matters whether the object is kept symmetrical or non-symmetrical. Let's make that how the three images are created, dear students. This one is a mirror. This one is a mirror. Dear students, I am taking an object here. For our convenience, I am taking it is at an angular bisector. Our object is placed at a place which is equal distance away from the two mirrors M1 and M2, and these two mirrors are at 90 degree to each other. Now, dear students, let both the distances are smaller, right? The object is L distance away from mirror M1, so its image will be made L distance behind the plane mirror, that is let I1. This is the first image, no problem. Again, this object is small L distance away, so the image will be just L distance behind the mirror M2, that is I2. The two images you have got, I1 and I2. Dear students, if we extend, imagine that this is extended in this way. This mirror M2 extends up to this, or this mirror extends up to this, right? Then what happens? Look here. This is L, so this is L. This mirror will make the image of I1. This I1 will behave like a virtual object for the mirror M2, and image of virtual object I1 will be made by mirror M2, that is L distance away, like this. Let it is I1 dash. Or you can say, if we extend this, then it is again, this I2 is a virtual, I2 will behave like a virtual object for the mirror M1, which is L distance apart, L distance away. That is why the image of I2 will be created at L distance behind the M1, right? So it is I1 dash and I2 dash is just coinciding, right? Colliding to each other. That is why the first image is this, second image is this, and third image is this. So the three images will be made. You can say like this, dear student, look here. Image of is made at I1, right? Image of O made at I2 by mirror M2. Either you say image of I1, virtual object I1 is created by M2 at I1 at this place, that is I1 dash, which is L distance apart, either from M1 or from M2, right? Or you say the image of I2 will be made at M1, image of I2, virtual object I2 will be made by M1 at I1 dash, right? So they are the image of I1 and I2 by these extended mirror will actually coincide. That is why they are the three images I1, I1 dash and I2 dash. You just can apply the spherical concept also. And it's a very simple. Look here, dear students, just draw this simple geometry. Now between these two, this is 90 degree, this is 90 degree. This is equal to this because the distance of image is equal to the distance of object from the plane mirror. Now dear student, this is common, right? This is common. Now the two sides and one angle. So these two are the similar triangles. So this triangle and this triangle is similar. Or you can say that this and this is equal, right? Now consider these two. In this case, how this is, or in this case, if you consider, look here. Dear student, here in these two, this is 90 degree, this is 90. These two triangles I am considering now. This is 90, this is 90. This image of the distance of object from the mirror M2 is equal to distance of image from the mirror M2, means this is equal. This is common. So again, look here. The two sides and one angle are same. It means these two are the similars, right? First you prove that these two are the similars, so this is equal to this is. And now these two are the similars, means this is equal to this is. Dear student, you can just imagine a concept that this is a center and this is take a radius of these three distances are equal, right? Assume it O is to be the center and just draw a circle taking this or this or this as a radius, and this circle will be like this. This is a circumcircle. You will say this is a circumcircle which is passing through these 3 points, and the 4th point it will automatically pass through the 4 point where the images of I1 and I2 coincide. Dear students, what I have done, I have taken these these two triangles and proved that these two triangles are similar. It means this is equal to this. Now we consider these two triangles. Now this is equal to this. In these two triangles are again similar. It means this is equal to this, this is equal to this. Now assuming O to be center, I have drawn a circle having the radius that much or that much or that much. Now it passes through O, I1 and I2. Automatically it will pass through the I1 dash or I2 dash, whatever you call it. It will automatically pass through that point, which is a point of intersection, which is a point of collision of two images of virtual object I1 and I2, right? So this was just a spherical concept that how the images can be created using the plane mirror. Dear students, the image between two plane mirrors inclined at theta. How it is? Look here. This is the mirror, two plane mirrors. which are inclined at an angle theta. I am not considering this time symmetrical, right? It means it is the object is not existing at the angular bisector, right? It is existing somewhere. This is your object, and this is making theta 1 angle from first one and theta 2 angle from second one. Any concept you can apply, right? Dear student, just draw a perpendicular to this. Here object is at theta 1. Just draw a circle. Here is the object. Take this. Let O is the center of the circle that I am going to draw, and this distance where the object is kept, assuming at the radii of the circle, I am drawing a circle like this. I am going to apply the circular concept in order to make the images between the two plane mirrors which are inclined at an angle theta, whereas the object is kept at theta 1 angle from the mirror M1 and at theta 2 angle from the mirror M2. There are many methods to apply. I am applying here the circular concept. Dear student, this object is at theta 1 angle from mirror M1 and theta 2 angle at mirror M2. Dear student, if object is at theta 1 angle, right, then the first image by the mirror M1 of object O will be at theta 1 distance, and that is I1 dash, or it is I1. Image of O, object O by mirror M2, which is at theta 2 angle, this will be again the object is at theta 2 angle from the mirror M2, so the image will be at theta 2 angle from mirror M2, and this is, let it is I2. Dear student, this I1 will behave like a virtual object for the mirror M2, and this I2 will behave like a virtual object for the mirror M1. First, I am considering that this I2 is the virtual object for the mirror M1. Now, at what angle I2 is from M1? That is a theta 1 plus theta 2 plus theta 2, means at an angle theta 1 plus theta 2. Dear students, don't be confused. Very simply, that first find out the angle at which image I2 is existing at M1 from M1. It was a theta 1, it was theta 2. The image of object O by plane mirror M2 is I2, and that is at theta 2 angle. So now from the mirror M1, I2 is at an angle theta 1 plus theta 2 plus 2 theta plus theta 2, that is a theta 1 plus 2 theta 2. So the image of I2 will be made by mirror M1 at the same angle, that is a, this angle is a image of I2 by the mirror M1 will be at the same angle where the virtual object was at the angle at what virtual object was existing. Virtual object I2 is existing at theta 1 plus 2 theta 2 angle from mirror M1. That is why the image of I2 by M1 will be created at the same angle, that is a theta 1 plus 2 theta 2. Now dear student, image of I1 will behave like a virtual object for mirror M2. I1 will behave like a virtual object for the plane mirror M2. Now find out the angle at which I1 is existing from the mirror M2. That is a, from mirror M2, it is, this angle is a theta 1 actually. This is theta 1, this is theta 2. So it is at an angle theta 2 plus 2 theta 1. So from mirror M2, I1 is at an angle theta 2 plus 2 theta 1. That is why the image of I1 from mirror M2 will be at the same angle, that is a theta 2 plus 2 theta 1, and this is anywhere here, and it is a I1 dash, right? It was the I2 dash and it is I1 dash. Dear student, successively will now I2 dash will behave like a virtual object, right? For look here how I1 was the image of O by mirror M1. So I1 behave like a virtual object for this mirror, right? So image of I1 is made by M2 at I2 dash. Now this I2 dash will behave the virtual object, right? For this mirror, the image being made by one mirror behave as a virtual object for the other mirror. This is the concept you will apply, and in this way you will find many images. Now, up to what extent this process has to be repeated, up to what time you will, how many times you will repeat this process, until you will repeat the process till you do not get an image back to the mirror. You will repeat the same manner, you will repeat the same process till a final image is not made behind the mirror, right? This is made somewhere like this. Then stops automatically. Why? If mirror is like this, right? If you have got an image here, then this is a normal position, so you cannot draw the ray diagram. That is why it would be the final image. Now, dear student, this is so many things you have to go through while you are going in this way. There is a method, very simple method, that is a crisscross method, and simply you can apply in this way. For example, this was the two mirrors, right? The angle between them is theta. This is plane mirror M1 and this is M2, and here is the object which is making theta 1 angle from the mirror M1 and theta 2 angle from the mirror M2. Dear student, this is the mirrors. Angle between them is theta 1 plus theta 2, right? This was at theta 1 angle from mirror M1. So image will be made, first image at theta 1, and by this at theta 2 angle. Dear students, next image that is this is theta 1 plus at this, so image of that is I1 dash, that will be at theta 1 plus this, that is 2 theta 1 plus theta 2. Image of I2 will be the virtual image of I2, the image of virtual object I2 you will say rather. This plus this, that is a theta 1 plus 2 theta 2. Again it is theta 1 plus theta 2. Now it was I2 dash. Now the virtual image of this will be at an angle theta 1, add these two, that is a 2 theta 1 plus 3 theta 2, right? That is a I2 double dash. In this way you can do, and the image of this, that is a I1 double dash, the virtual image of this one, or the image of this virtual object, this plus this, that is a 3 theta 1 plus 2 theta 2, in so on you can do, right? You can do till this individual doesn't crosses 180 degree. If it will cross 180 degree, then image comes just after the 180 degree, image comes behind the mirror, so you have to stop doing that, and that will create the number of images, right? If at this position you have got it is even less than 120, 180, then the number of images will be 1, 2, 3, 4, 5, 6, like so on. Let's take one by one some another examples. This process can be explained easily just taking the two mirrors perpendicular to each other. This is M1 and M2. The angle between them is 90 degrees. First, I am taking the object is symmetrical. And less symmetrical means it is at 45 degrees. This is at 45 degrees. Right? And object is somewhere on this line. This is the object on this line. Now, using the crisscross, let's check that how many images are made. You know, the number of images will be m is equal to 360 over theta minus 1. 360 over theta is a 90 minus 1, 90, that is 4. This is a even number, so result will be 4 minus 1, that is equal to 3. The formula says whether it is kept symmetrical or non-symmetrical. In both the cases, we have to get the 3 images. How? Let's check by the crisscross. The two are at 90 degree, right? The two mirrors are entangled at 90 degree. Now, dear student, image of that will be that, and now the object is kept symmetrical means at an angular bisector between the two plane mirrors M1 and M2, right? Dear student, image of this, that is I1 at 45 degree, and image of this object, the object O by mirror M2, it is I2 at 45 degree. Now, image of I2 will be here I2 dash at an angle for 90 plus 45, that is 135 degree. And image of I1 will be, that is I1 dash, right? And angle will be again 135 degree. Again 90 degree. Dear student, look here, 90 plus 135, now it crosses. Now it crosses 180 degrees. So you have to stop the process here. Now dear student, how many images are made? 1, 2, 3, 4 images. But you know your answer is 3. Dear students, what happened? Now add these 3. 135 plus 135, 270 plus 90, 360. If it comes 360, it means that these two images are coinciding to each other. So finally, there are the 3 images, 1, 2 and 3. These two images coincide because the sum of these 135 plus 135 plus 90, that is 360. So the 3 images, these two images coincide. So finally you will get I1, I2 and these, they will coincide. So one image, so they are the 3 images. Dear students, what happens? Let object is kept that it is making 30 degree from M1 and 60 degree from M2. Now let's test how much images will be created just by crisscross, by spherical, any method you can apply. This is 90 degree between mirror M1 and M2. Object is at 30 degree from mirror M1. Object is existing at a line which is making 30 degree from plane mirror M1. So the image of this will be created on a line which is making again 30 degree, right, from mirror M1. So it is let I1 at 30 degree, and here object is at 60 degree from M2. So the image of this object by mirror M2 will be made at a line which is making 60 degree, let it is I2. Right? Dear student, the virtual image of I2 will be I2 dash at an angle 90 plus 60, that is at 150 degree. Right? Now, virtual image of this I1 will be I1 dash, and it will be at an angle 90 plus 30, that is 120 degree, and this is a 90 degree. Now dear student, if you add these 3, Again 150 plus 120, that is a 270 plus 90, 360. Again these two images will just coincide, will collapse. So there will be 3 images will be made only, right? Dear students, this is the way that m is equal number of images, m is equal to n minus if 3 upon 360 or theta is n, and if n is a even, let the two mirrors m1 and m2 are inclined at an angle theta, and 360 or theta is equal to n. And if n is a even, then number of images will be m is equal to n minus 1. I have proved by many methods to this. And if n is a odd, and if n is a odd and object is symmetrical, symmetrical means making same angle from m1 and m2, then again the number of images will be m is equal to n minus 1. If object is not symmetrical, it means it is not making equal angle from m1 and m2. In that case, the number of images will be m is equal to n, but the condition is that n is surely odd, right? N is surely odd. This is today's topic, dear students. It was the plane mirror. So many things we have to discuss much about the plane mirror. But after that, the video will contain the spherical mirror spherical lens, like so on, mirror formula f equals to r by 2, 1 upon b plus 1 upon u equal to f. That we will prove, and so many problems we will solve regarding to the spherical mirror. After spherical mirror, after that it will be the next video will be on the spherical lens. So I hope, dear students, that you must will be following me. If you think that my videos are fruitful to you, then please like, share and comment on the videos, and do subscribe, and must put the bell icon so that you might be notified about my next videos. Thank you.